everyone, welcome back to our AP Calculus series, and today we're going to go over a test for divergence and convergence. So there are 7 major tests for convergence and divergence, which are a geometric series, it's an nth terms test, the integral test, the harmonic and p-series test, and then is a comparison test, alternating series test, and lastly the ratio test. Okay, so let's start with the geometric series test. So from the name you may already know that we use this test when we have a geometric series. So if the R of the geometric series is the the absolute value of the R is greater or equal to 1, then it means it diverges. If it's smaller than 1, then it converges. So for example, a divergent geometric series will look like this: 1, 2, 4, all the way to infinity, where R equals to 2. And convergent geometric series will look like this: 1 over 2, 1 over 4, all the way to 0. And just one more thing to mention is that when the R is smaller than 1, the sum equation would look like this: the first term over 1 minus the R. Okay, and now let's move on to the second test, the nth terms test. So the nth terms test is very straightforward. It means when limit of n approaches infinity, so an would equals to when an doesn't equal to 0, then the series diverges. However, when a particular thing that you need to note for this test is that we can only use it to test if the series is divergent, but we cannot test it for the convergence. Divergence only. Okay, and the third one is the integral test. So the integral test basically means we take the integral of the function, and if the integral equals infinity or negative infinity, then the series diverges. Otherwise, if the integral equals a constant, which means it's a number, it's an exact number, then the series converges. Okay, and the fourth one is the p-series and harmonic series. So for this one, the sequence will usually look like this: n equals to 1, 1, and p, something like this. Or you can have a polynomial as a new denominator. So for example, np plus np plus 1 plus 1. Okay, so in this case, if p is greater than 1, then it means convergence. If p is smaller or equal to 1, then the sequence diverges. So the p is the exponent. It's actually pretty simple to memorize because because it's always 1 over something or a constant over the end of an exponent. Therefore, as the exponent getting bigger, then the value gets smaller. And in this case, where we have a polynomial as a denominator, we just take the biggest one. We just take the leading degree. The leading term to do the to do the test. So if np, so if p is greater than 1, then converges. Otherwise diverges. And the next one is comparison test. So for this test, it's basically you basically use it when you have 2 or more series. So for example, if you have one series an and another series bn, and an is smaller than bn and they're all greater than 0, then if an diverges, then bn must also diverge. If the bigger series, in this case it's bn, converges, then an also converges. And another thing to mention is that we only use this test once. We only use this test once. An over bn. It's a specific number, which is a constant. Okay. And the second last test would be the alternating series test, the number 6 test, alternating series. So we use this test when we encounter an alternating series which look like this: 1 minus 1/2 plus 1 over 3 minus 1 over 4 plus 1 over 5, blah blah blah. And I write it in sigma notation. It would look like this: -1 n minus 1 over n. And let's call the 1 over n to be a. So the alternating series test tells us that if first then n approaches an equals to 0, and second, if an plus 1 always smaller than an for all n, then if all these 2 conditions are met, then the series converges. Okay, and the last one is a ratio test. The last one. So the ratio test tells us that first, if an converges when n approaches infinity, an plus 1, an is smaller than 1. Second, if the thing n approaches infinity, an plus 1 an is bigger than 1, which means the terms are increasing, then diverge. But if lim n approaching infinity, an plus 1 over an equals to 1, then the test fails. Which means you need to find another test to determine whether it's converges or diverges.